So in the last video, we saw that how functions are working, what is a function, what is main, how we are showing output to a particular part of the function, which is your computer, maybe another computer. So those things are also function. And that's the most crucial concept to begin with. But now we also have to look, we just don't want to show, we also want some input from the user. As I talked about the example of ATM machines, the machine which gives you the money if you have the money in your account. And you could also get the example, you can also think of the example of what do I say, your machine right now, whatever you're using, your maybe your mobile phone, maybe your laptop, or maybe your desktop. So these also are getting some sort of input, and they also getting your input at the point, and where you are feeding your input by touching the display or maybe the keyboards. So taking the input from the user is most crucial thing. After just not, we're not just here to calculate. Computer is all about sending the data and getting it back. That's what a computer does at best, and maybe sometimes compute something if you want, but basically it's all about storing and getting the data retrieval. So now let's look at the how we're going to get the user input, which is our own input, so that we can work upon a certain logic. We can calculate certain things, we want to do certain set of operations. So let's try to get into there. So one of the first thing that we saw in our code, oh, oops, there's a problem, is we looked at that how cout is working. This operator is directional, so first thing is going to be this over this, then this. Actually it's like this thing is going to be there at the first, then this thing, and it started to send stream from left to right. Got it? And you could also put anything right here. It could be any file also. So cout is right now is sort of a function. If can we see its definition, like no, so as you can see that it's linked to standard input. Extern means it's an external file, it's coming from an external side from the standard, and o stream means it's belong to the output stream. Got it? So this is its definition somewhere in this file iostream, and we saw that. Now how to get the input from the user, we saw getting the output. I did talk about the directional operator right here. So instead of just getting this, let's try to remove this. Maybe try to comment this out, and let's try to comment this out also. Or maybe we could get rid of all of this and just put a return expression here, 0. That means that everything is kind of working fine, to tell the system, hey, everything is working fine. So now let's try to get input from the user. So for that, let's first of all tell the user, because whenever we go to any website, Facebook or anything, there is this form page which tells that what do you want to do. You want to put some sort of input, you want to do login. So it tells that, hey, type your email here. Got it? So we're not getting the email, but just what we want is enter a number. Oops, that's my mistake. And here we can put a semicolon. A semicolon just tells the system that, hey, that's the end of the line. That's the syntax is still here, and you should move to the next line. That's it. Because your compiler, what it does for optimization purposes, it removes these lines, these spaces if you are putting here, and it just gets rid of that. Now here, for that we need a directional operator. So where we want to put this input. Okay, now you're gonna see, you want to say like, we haven't have anything to store with. So that's where the part of memory came into play. Is there anything wrong? Yeah, something just went with the display. So here the play comes into the picture, which is dealing with the memory. We saw earlier in the video, I've explained what memory is, but now it's the time to see that how memory is going to work. So before that, let's try to also get a place where we want to store this thing. I'm going to explain everything, don't worry about it. So we want a number, and for that I told, I think in earlier video, there could be like an integer. We want an integer. There could be like two other like there are two types of number. I'll explain. But for the first and the simplest thing which we can have right now is, let's name this as num. Okay, and let's put a semicolon here. Okay, if you put two semicolons, it's just gonna show you any error. It's gonna treat as an empty line, or maybe just as just nothing. But it is something, but for the system it's like the compiler came here, and if he saw another semicolon, it's gonna treat this as blank entirely, and just going to skip everything here. Got it? So you don't have too much worry about it, that what if I, but it's better to put semicolons. Now here, if we try to say num, what is going to happen is the first thing is going to be showed on the console on this machine, because we are in the standard namespace. This entire namespace, this place, this entire space is going to be standard. And so we're using standard console output, and we are also using the standard console input. And this thing, as you can see, is this here. So the IO stream header declares 8 standard stream objects. You can, if you want to read about that, you can read more about that here. There is this manual, but this is basically it. And iStream. Okay, so let's try to run this and let's see. Oh, we haven't, showed any output. So if I wanted to send 5, it is taking the 5. To get better at the output, we can put more space here, and we can also, provide a colon here. Could also, create more space over here. We can do also that, so it could look good. And we can also do the same thing. So we can do the number you enter is, doing that and just having this space. And again, since this operator doesn't overrides, you can tell it's num. Okay, so after having this, you can also, to for a better output, I'm gonna tell you, we discussed this in earlier video, but let's try to do that, like whether we able to get the input or not. So if I press 5, maybe 6, let's this time do something like 8. How about 8? And the number you entered is 8. That's great, it's working. But again, see, there is a little bit of clearance we can get from here, from in the input and the output also part. So what we can do here is we can introduce the same thing, which is called as the new line. And this new line operator is nothing but, well, I'm going to explain it when we're going to touch the string part, like how is it being stored and what is going on here exactly. Okay, we're gonna take another example for that, a real world example, but for now we're just going to see the how you take the input and how you're gonna show the output. And we can also do the same thing in the front. How about that? Is it going to change? See, the color is also different here because it's gonna treat this as single entity now. The compiler, the smart, this editor is telling you the color here so that you won't be miss, so you won't make any sort of mistake. These color codes are being there. So as you can see now, if I enter, if I went on t, it's, the n number is 0 because it doesn't know what to do with this t. But for the sake, you should be entering t. That's what this integer in front of this does. So the compiler knows that this number is going to be an integer type without decimals. What we mean by that is, if you try to enter something like 67.9, it's going to take the 67, it's going to discard this rest of the part. That's what this integer is telling. We're going to see what that is. Okay, so now we're storing something here, and exactly it's not being stored here. It's something called as name. So I also have discussed an example of you yourself as a person. Sorry, that's my thing. I have actually have explained you belong to an Homo sapien class. You have a name, but you are something else. You belong to a space in your home where you live. So this is somewhat like that. So what are we doing here? Where is my is my drawing tab connected? Okay, it's got disconnected. My bad. Sorry, I have to connect this. Give me a moment. Let me just this here, and I don't know how I just got disconnected. How I why I did that, I don't know. So where was I? Yeah, okay, got it with the back. So what I told about you is that you are a person. You are a person. You have a name. Okay, that name could be, for example, let's take Rohan, my friend. So this is Rohan, and he has certain other names. For example, we call him, Mess. No, we call him Ronaldo. Okay, he plays quite a good football, so we call him actually Ronaldo. And we also have this name. There is Rohan. This is a name. And Rohan belongs to what? Homo sapien class. Homo sapiens. All right, It's not Roman. I also sometimes call him Roman, so you can call him Roman too. and he currently lives outside India. So over there, he is being referred as Indian. So when I say Rohan, does Rohan consist of he himself? Like, no, that's a reference, that's a name given to him by his parents. That's just a name, or just a reference, not Rohan itself. So Rohan is itself a something called an object, something which exists in real world. So before getting birth, Rohan was some sort of like a map with DNAs. Sorry, that's not a DNA. Let me draw the DNA. So Rohan is somewhat like this DNA thing, and it's been encoded. It's like a structure where Rohan was there, and it's like a blueprint. So your computer machine also consists of some sort of blueprints, and once it takes a form, it started to exist in the machine, in the memory, in the world. It becomes an object. Got it? That's something, a concept coming from memory. So I'm talking about right now memory before hopping into this integer and all this thing. So Homo sapiens is there, Rohan is there. So what that is? So Homo sapien Rohan. Should I use another color? Wait, let's use another color for that so that you could see it better. Rohan equals what? You can have the object. So this is what Rohan is. Yay. So Rohan is this. Got it? This is exactly what we are doing in the machine. We're telling it belongs to an integer. There is something called as name. We're giving it a name. It's like a reference. It doesn't mean that this number consisted of this 5. The Rohan itself doesn't consist. It could be changed. The reference could be made to something else. Like you can think of R as 5 now, but R is somewhere else in the memory right now because it's a unique thing. There are a few other concepts in other programming languages. In Python, usually it's being referred to same place sometimes, but if you're making a reference from here, it doesn't. But if you have eliminated the reference, sometimes what does the system is try to avoid recreation of this thing to avoid resource consumption. They kind of assign it, but we're not getting into that part too much. So Homo sapien is Rohan. That's how somewhat it's what we did was int num equals 5. There could be multiple references of the same thing, belongs to the same object, and that's okay, that's fine. Okay, so Rohan is somewhere by called his parent as this, then Ronaldo Roman, we friends commonly call him like that, then Indian outside of India. Okay, so there are few things to tell earlier that what it is, where it belongs to. So the first thing, in real world you deal with numbers in integer, you dealt with numbers in in decimals. You also dealt with something like strings. You sometimes dealt with characters. Characters are the building block. So characters is the very common component of this collection of characters. Somewhere you can think of that the collection of characters kind of make the strings is like your entire paragraph which you're writing, the email address which you're writing. So your email address is going to be a string. The characters is somewhat like the yes or the no which you check on the checkbox, that what you could be like a male or female, okay, or maybe the third. So that could be like the third gender. So you could be like any of these things. So a single character is there to represent that. In real world, if you see that even in the application forms, you sign what's your gender, and over there could be like 3 boxes and you can tick any of those things. Now ticking those things could means that either it's going to be true and rest are going to be false. You cannot like do both of them. So for that we also have something called boolean. Why boolean? Because boolean is means 1 and 0, and that 1 and 0 is simply in machine is a high voltage and low voltage, which is being, that's how your computer machine actually works, in ones and zeros and nothing else. So integers are represented with, let me use some different color for pen. Oh, okay, wait, let me increase its thickness. So if I want to this, how about that? How's it? Integer with decimals, there could be like 2, but basically it's float. I hope that this is being visible. Float is there. And for float, float is basically something having a precision of around 7 decimal values. That means that after decimal, for example, if you have a number called 97.6666666, is it 7 1 2 3 4 5 6 7? Yeah, so that's its limit. But what if you have some sort of a scientific calculation? How would you store? Because it's not enough to store a scientific calculation, you need more space. Now for that, you could have something like a double. That's also a part of decimal. It's like flute but on on steroids. It could have like a 15 places after decimal, so you could store more. And so if you're storing more, that means that its size is also bigger. But or if it's the size is bigger, that means that it's a little bit costly to allocate memory space, because decimal system, because a decimal number doesn't stores in altogether, it stores in a broken part. Actually, if you went into computer organization subject, over there it's been discussed that the first part before the decimal is stored somewhere else. Got it? And it's somewhere else in the machine. So that's how it works. So double is something you can work if you want to increase more of it. If you really wanted to increase double to something else, there is something called as long double, which increases its more size, and you can have more values into it. Got it? So if you wanted to store more values but don't want you know getting out the side of the negative numbers, it also it's limited. One thing you should know about your machine, it's finite machine. It's basically a finite automata. Whatever you are using nowadays, it's also called a finite automata, and it's finite, it's range, it has range. So you should be careful when you're using these things, because see, the infinite in mathematics isn't been defined. It's just there, like there's something such a big thing which we cannot express right till now. So that's what it is, and you should be not too much confused about. You can read, you can go on Google and search about that. That's sort of a task that you could do. Won't be doing it, because if I started feeding everything from the spoon, it's not going to work, it's not worth it. So try to search. That's how I learned, and that's how you could learn more well. Okay, so decimals are done. Then there is this string thing. What that is, I did told about, like there's this code thing. So let's try to get into this, and let's try to see that how memory works over there. When we stored something called as integer num equals 5. I hope this is visible. If it's not, like, let me change the color. Okay, so integer num equals 5. What happened then when you took this like this, it's sending it to num. So console input, where you're inputting it, it is sending this thing to where? Num. Now num is a not storing this thing. Num is actually pointing to some place at the memory. Basically, I discussed this about in memory video. So num is not storing this, and num basically is pointing, and now this thing is stored over there. Why this is? So for example, how do you understand this? For example, you can think that there could be uh, your friend's home. So your friend lives at a place which is a little distant from you. Okay, so you live in this block maybe, and memory is divided in block. Got it? Block, just like how the blocks are divided in our. Is it not visible? Got it. Wait. So I gotta have to shift this a little here. So memory is basically divided in block, and your friend might live over this place on the block, and you might be pointing like where he lives. He lives over that block. So you're pointing it. And that block, the house is built, that means the address is there. The plot number is going to be. So for example, take this x10x, and you basically have a name, your friend's home, friend, or maybe my friend. That's how you name basically in computer machine. Basically either start with an underscore or my friend, or maybe like this. But you could not use you basically cannot use hyphen and all this thing. My friend, you cannot start with integers 10 my friend. No. But you can do this thing, my friend 10. So you can do these sort of things. Okay, it's not deleting. Oh yeah, it is doing. God, I thought like it's not going to do it. It's not doing anymore. So let me just get rid of this. So you saw that your friend's house is going to have a memory, place, address, and you named your friend's house as my friend's house. Okay, so that's a name. That's just basically a name. It doesn't it doesn't hold this thing, but it points to it. You're pointing that my friend is there. That's exactly what is happening. So num is telling the compiler, hey, it's over here at x10x, the 5. I'm the name. So you could refer this name. It's just for your convenience. You can also use this thing. That's the leverage which C++ gave, so that you can optimize more. You can deal with this thing with the help of pointers. Got it? So how to extract out the address? If you want the address of a place where this thing is stored, if you want to deal directly with it, it is called as this operator, ampersand, which also placed on the 7 button on the above Y key on a keyboard. So if you place ampersand num, it's gonna give you the address. Got it? But if you really wanted to point what is on this address, you could use something like this operator, asterisk. This thing is tells the compiler, hey, it's a pointer type. It points to a place where a thing is stored, so you could better hold the memory. It's simply, you can think of this as a very simple way in the terms of engine efficiency. So if you know that how to make your engine more efficient, maybe you want to increase, maybe not the efficiency is your case, but you want to increase its horsepower, you want to increase its power, you want to, do more, sort of you want to put more fuel into the engine so that it could burst out and it can go 0 to 100 like quickly. So you want to do that, you can tweak it. And the only way you can tweak it, if you know that how engine works and how to deal with the walls. That's the same way, memory. If you know how to deal with memory, you can optimize it better. So that's what these things under the hood goes into. Num doesn't holds it, but an address at the place. Your friend's home is at a address x107, but you named it like it's my friend's home, it's Rohan's home. Can you see it? No, Rohan's home. So you can remove it. You can also assign this address to other. So if I say Roman, and if I give it an address of this, what? Rohan. That's how you give the address. Oh, sorry, this. You're assigning this address to this. Simple. You can also give that. So that's it. That's how memory works. Now, same thing is going with this. If I say this num thing right here, so num is there, then you are having what? Here is string. And now this string is also stored somewhat like this. So if I go and here and started to, tell you about like how this string is stored. So for example, take the example of hello, a simple string. These codes are only for the compiler, not for the machine. The compiler, as soon as it encounters this double quote, it's now know that, oh, wait, something is coming, which is a form of, could be a string. So it started to read, and as soon as it reaches this point, that means the string is concluded. Got it? But the memory location doesn't know whether it's concluded or not, how it is being stored. So this is how it is stored. Remember I told you about characters? So HELLO, and at the end it sort of ends with certain character, a special character to tell the reader at the memory that, hey, this thing is kind of ended here, so just don't go further. Remember, I told you that there is something called as pointer, and that pointer actually pointer. Does it point to entire thing? Like, no. So for example, your friends, you could think of that your friend could live all together at the same place in individual houses. You can think of this way. So you want to tell the direction to, hey, where your all of friends live, and they all live all together at just one house. Maybe it could be, hostel rooms. You can think of that in that way too. So you just point to the beginning, x107, and you be like, next would be there, next would be there, it's in the next. So how would you approach? You just only have to know the first address, the first room number of your friend's hostel room, and you don't have to go to bother about what are the rest of the rooms. You can tell like it's in the next, it's in the next. So for example, this thing could be named as what? Let's give it a name. It's like ST. So this thing is named as ST. So ST of 0, that's the very first address. 0 is the beginning, it's the starting point. It's not 1. 1 is not the beginning. Beginning is 0. Remember, it's the initial thing, it's the initial state of the machine. It's always begin with 0 off state. So you are having 0 in the memory, it's the beginning. So anything which is starting in machine, it's always going to be 0. Then how to point to the next? It's 1. So st of 1 is going to what? E, because only a single thing could be reside on the over this memory cell. Then LLO, and this thing right here, this the same thing as slash n. It's a special character which is being inserted after strings, usually in C++, to tell the machine that hey, when you started reading here, 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 and as soon as you reach here, it tells the machine, hey, whoa, whoa, we ended. It's the same concept of the train. So your train is connected, but at the end there is this special bogie which is being attached and tells like it's ended here, because you just don't know where it is ending, because you never visited this place. You can think of that train is passing from that station, and the station master doesn't know how many coaches it's going to have, how many bogies it's going to have, and all it knows is that as soon as he or she saw this thing, that means it's ended. Simple. The same thing goes here. It's like a train, a stream, a string is like a train, and this thing tells like it's the end. If it doesn't know, it doesn't know that whether it is being ended or not, where it is going. It is going further, or it is just being broken somewhere else. So that's how your memory is being stored. That's how, oh sorry for that, that's how memory is being stored. That's how memory, usually stores strings, your decimal. So we talked about 25.26. It's basically not stored as all together. If you think, it's kind of complex, I'm not getting into it. If you want to read, you can go through. The 25 is being stored here, then decimal is stored somewhere else, basically in the memory, and then this 26 is also stored somewhere else, and then later on these are being pointed at a place. So as soon as you call that, hey, where is my decimal, my deci, so as soon as you point, it sort of all points all together. That's somewhat like float and your double works. Got it? So this is what these things all about. And if you wanna, should we talk about null here? You can think this operator as the null operator. Basically, it tells the machine that hey, we are ending here. Okay, let me take another pen. So you can think this thing as null also. Okay, so it tells that it's like stored somewhere. It's like a place, it's got stored at the memory place, and it just represents like nothing. So basically it's a German word, so it tells like it's nothing, and it's tell like it's same as like this cross. It's just there, which does exist, but it's be like it means nothing, like it's nothing. So you should be worried about, you should know about this. Okay, and that's somewhere how your memory stores this num. So when you're getting this thing, now where these things are stored, are these being referenced? Like no, these things do stored into the memory in the stack. So I told about this in the memory video. If you have anything which is dynamic, you don't know how what the size could be, it went into heap. Okay, let me increase its size a little bit more. And how about making it this colorful? Like how's this? Is it, oh wow, that's cool. So heap is there, and then there is the stack area. Basically your everything, whatever you run is stored in this stack place. Okay, your even the function, the main right now is in stack. It takes a place in stack, the computer assigns a place, and the main is somewhere pointed here. So everything you do is here. Rest of the thing could be pointed to a place into the memory itself again. It's a pretty complex thing. It's not that complex, but it's quite easy to understand. So that's a stack. That's how it's stored. So what we saw integers, we saw float, that means a decimal, we saw double, We also saw if you want to increase, because it belongs to a negative to positive range, basically your decimals and integer. But if you sure that you want to deal with bigger numbers, because usually in scientific research you are dealing with this, so you can also do this thing, long int or long double. It increases the rest of the size, and you can work with that. It's quite easy, not that intuitive or difficult to grasp with. Okay, let me try to change the pen, increase its size. So it's long, then long double here, negative, positive ranges are there. It's a finite thing. Remember, strings are also finite. There's a limit also. You can also get, a lot of amount of string, because thanks that databases are now so optimized. There is a data structure called tree. We're gonna see this linked list also. Linked list. We're gonna see what these trees are also. Don't worry about that. These things are being implemented. These trees are being implemented into the database where these files are being stored. It's about like this structure. Your arrays is like this. Arrays we're gonna touch upon. You got the idea of strings. That's exactly how arrays are also. So if any problem you arise with arrays and strings, you can go interchange them. Easy. Now the thing is character. Character. Character is like a single thing, like a single quote a, then there could be b. Basically these things are again being mapped to a value. For example, character a, this thing is mapped to 65 in decimal. I hope you're not able to get this color. So 65 is there. 65 is used to represent this. Why? So that you could easily translate this 65 in one zeros, one zeros, one zeros. It's easy to do it. Besides that, so for the easiness, we are having 65 to represent this. I think it's being represented by 97. These things are mapped. See, I told you that your compiler refers basically to a grammar or rules. Got it? It basically works from that. It refers to it, and then it validates whether you have wrote something right or not. So as soon as it sees a, it's gonna see it's in grammar, like, hey, where this thing is, and it's gonna see, okay, so the a is there, something, it's a, and it's being mapped to something called 97, and then I can convert this 97 to 10101001 for the better memory optimizers. That's what exactly your computer understands, this thing, not this, but your computer understands this thing. So character is like single thing. You can have this, anything which is being present on your keyboard is a character. Okay, so it could also take a m, anything like that. Got it? So that's what a character is. The combination, somewhere you can think of that characters combination, char plus char, gone up somewhere like string. Well, you cannot do this thing, but I'm just telling you that it's single characters being are collectively all held together. Okay, we're gonna see another example in the next video. It's going to be all about strings, where you're going to understand more about strings in a much easy and a composable, understandable way. I think you've got a pretty good picture around here. Now let's delve into a little bit more into void, and we're gonna see these types and all this thing a little later. You don't have too much worry about that. Okay, now how about like taking multiple inputs? So should we continue doing that or not? Or maybe let me just pause this video right here. We're gonna see it in the next video. I think that would be much better. It would be become like again an hour video. I don't want that. So instead of making this as an hour long video, I'm gonna pause here, and we're gonna see in the next video that how you can have more of inputs, how you can, I think you got the idea with those operators which I told you, that it doesn't overrides, but what it does, it's kind of stack it all together and pushes one after another. So that operator is quite useful, as you can understand. If you want more, if you want to understand it about more, you can go and refer to the Linux video. I've explained that over there with file system. And I think that's it for this video right now, so we'll see you later. Okay.